Okay, I'm going to now show you 3 different questions on calculating the moment about a line. So this is the moment of a force about a line rather than a moment about a point. Okay. Right, so this first question, I'll just label it question 1. Determine the magnitude of the moment of the force about, and in this question it's about 3 lines. So there's 3 answers. The force F about the axes X, Y and Z. Solve the problem A using Cartesian vector approach, so the vector approach, and B using a scalar approach. So that's in the traditional way you would have done it before doing vectors. So let's have a look at the problem here. We've got a force acting at this along this vector. Well, this is a force vector. And we've got this arrangement of pipes and the force acting this way, and it says calculate the moment about this X line, this Y-axis line and this Z-axis line. Okay, so first thing we do with all of these geometry questions, we write down our coordinates or position vectors of each of the coordinates we're interested in. So A is, well, 0, 0, 0, it's the origin. B is, so 4, we look at the diagram 4, Y is 3, and Z is -2. Remember to get these signs right. Getting these 3 coordinates is key to getting anything right in this question. So C is 4, 3, 0. It's in the plane, XY plane. We're going to always need some vectors joining these points, or lines joining these points. So let's start these vectors now. So AB is equal to B minus A, which equals 4, 3, minus 2. It's just the same as a position vector. AC is equal to C minus A, which will be similarly just the same as what we have C is up there. 4, 3, 0. We're going to need CB, I think. So that will just be B minus C, which will be 0, 0. And it's -2, -0, -2. Okay. So, key to this calculation about the moments about a line is this formula. So I'm going to say moment of a force vector F about a line is, so the moment is equal to the unit vector dotted with a cross product of a so let's say unit vector in the line. R is a position vector from any point on the line to the point of action of the force, and F is equal to the force vector. So the first thing we need to do is look at for each question to get the unit vector. So in this case it's quite easy for the three parts because the unit vectors are in the x, y, z axes. So let's write this down. We'll write u, and I'll call it x for the x direction. The vector is simply 1, 0, 0. U in the y direction is equal simply 0, 1, 0, and u in the z direction is simply 0, 0, 1. So R, what is R going to be? So let's look at the geometry again. Now it's from the force, we need a vector that goes from the line to the force. So it could be any vector from the x direction, say. And so that last one I've drawn is come from point A. It turns out point A is on all three x, y and z axes. So we're going to use point A for each of the three calculations. So this R vector, so R is equal to the A, B vector. Let me know about that and draw that slightly better. It's this AB vector. Okay, so R is equal to AB. And I'm going to write for example, because it could be many other vectors, but AV is the most convenient. So we can easily write down a moment in the x direction is equal to ux dotted with AB crossed with the force vector, which we write down as ux 1, 0, 0, AB, we calculated it earlier, 4, 3 minus 2, and the force vector 4, 12 minus 3. Okay, so we expand that. That'll be equal to 1 times the determinant of 3 minus 2, 12 minus 3, which equals minus 9 minus 24, which equals 15, and we can write Newton meters as the dimensions of meters of the force in newtons. Okay, so we're going to write a similar, so that's the moment of the force about the x-axis. It's not a vector, it's a scalar. Okay, so we'll do a similar thing for my. which equals uy dotted with, again it's AB because A is on the y-axis, crossed with F. And this is then 0, 1, 0, 4, 3 minus 2 as before, and 4, 12 minus 3 as before. And this will be minus 1, 4 minus 2, 4 minus 3. And we can expand that to my equals minus 1 times minus 12 minus 8, which equals 4 Newton meters. And similarly, mz is equal to uz dotted with AB cross F 0, 0, 1, 4, 3 minus 2, 4, 12 minus 3, which equals plus minus plus 1 times determinant of 4, 3, 4, 12, which equals 48 minus 12 equals 36 Newton meters. Okay, there's the three moments of the force about each axis. In terms of scalar calculation, mx is equal to the sum of moments about each component about the x direction, and we look at 12, so we ignore we've got the force, F is equal to 4, 12 minus 3, so we're 12 times the distance, which is 2 meters, minus 3 times 3 meters equals 15 Newton meters. My is equal to the sum of my, which equals minus 4 times 4 meters minus 3 times 4 meters, which equals 4 Newton meters. Z is equal to the sum of the MZs. Oh, that's Z. Which equals 4 times 3 meters minus 12 times, so that's plus 12 times 4 meters, which it comes to 36 Newton meters. So these are all the same, 36, 36, 4, 4, and the 15 was on the sheet before. Okay, we're going to look at question 2 in this series of calculating the force, the moment of the force about a line or about an axis. This question is the same arrangement as what we had before, a system of bars connected there, and a force, and it's the same force factor. But this time it asks what is the moment of the force about an axis between A and C. So that's drawn on the diagram, A and C. We're going to be labelling that at line AC. But it's pretty much the same calculations as before. What we're going to be doing is a calculation where the moment is equal to the u of a position vector to the vector to the a position vector in the line AC, a unit. Let's say that again. UAC is a unit vector in the line AC, dotted with a position vector from any point on the line to the point of the force. So you can see that might be BC, or it might be a vector from A to B. Okay, so that could be any position vector crossed with the force vector. Okay, so if we know we're going to calculate that equation, then what we need to at least find is this vector AC. But let's just write down our, as we did before, the position vectors of the points that we have. So A is a 0, 0, 0, B 4, 3, minus 2, and C is equal to 4, 3, 0 as previously. We're going to have to calculate A, the unit vector in AC. So let's calculate AC to start with. It's equal to C minus A, which equals just effectively equal to C. U AC is equal to AC over the magnitude of AC. So be 1 over square root of 16 plus 9, which we know is 5, times by 4, 3, 0. So 1/5, 4, 3, 0. We could put that 5 in the vector, but I'll leave it out for now. Now, a position vector, as I said before, it could be it's from the line, so maybe a point on the line to B, so point C to B, or it could be A to B. Let's try C to B. Okay, so we need to find the vector CB, which is just B minus C, which is 0, minus 2 minus 0 minus 2. Okay. So we'll do this calculation now. M is UAC dotted with CB crossed by F, which will be, I can put the 5 outside the determinant, the fifth, 4, 3, 0, CB 0, 0 minus 2, and F is here, 4, 12 minus 3. There's various ways to expand this. Let's expand on this second row because there's only 1, 2 there, so it's going to be plus minus plus minus plus minus, so it's minus minus 2, so multiplied by the determinant of 4, 3, 4, 12, which is equal to 2 times 48 minus 12. Forgotten the fifth, times by a fifth. So 2 over 5, which comes out to be I'll get my calculator to do that calculation. 36 times 2 divided by 5, 14.4 Newton meters. Okay. So we could have done that same calculation using CB. So in fact we did that with CB. So that, yeah, we could have done a calculation using this green line here, which is AB. Let's just do that. Let's just calculate AB. This is all we have to do different, which is B minus A, which in fact would be equal to B, so it's 4, 3 minus 2. 4, 3 minus 2. So the M, and we're going to get the same answer, U of AC, unit vector in AC, dotted with AB crossed with F, which will be 1/5 again of 4, 3, 0, and AB is 4, 3 minus 2, and F is 4, 12 minus 3. We can expand that, 1/5 outside, and then 4 minus 2, 12 minus 3, minus 3, 4 minus 2, 4 minus 3, and there's no y, so okay. If we expand that, keep my 5th here, so it's 4 times minus 12 minus 24 minus 3 times minus 12 minus 8. And if you do that calculation, you will see that that moment is equal to 14.4 Newton meters. Again, these two are equal. Okay. Let's look at one more question. So here we go. We'll take question 3 here. Determine the moment produced by the force F about the segment of the pipe assembly AB, segment AB. It's just line AB in my terminology of lines, so we're going to use that vector. So the process, as before, write down the coordinates. A is equal to 0, 0, 0 again. Zero, 0, 0. B is equal to 3, 4, 0. C is equal to 3, 4, and in the Z direction 4. We're going to be calculating M is equal to unit vector in the line AB dotted with a position vector. Now we can look at this. The force is up here, we're going to have B or we're going to have A as points. So we can have a position vector which is BC or AC. So, but that will be R. In fact, I'll just put on there. This could be R or this could be R. Crossed with the force vector. So let's do AB is equal to B minus A, which is equal to 3, 4, 0. UAB is equal to AB divided by magnitude of AB. Which is 1 over root 9 plus 16, and we know that's going to be 5 times 3, 4, 0, so 1/5 of 3, 4, 0. Let's also, while we're doing this, we'll work out the vector BC, and the vector BC is C minus B, which equals 0, 0, 4. Okay, so we can now calculate the moment, because this, we'll use this as the vector. This BC, we need R, we'll say that is equal to BC. We can do later that R is equal to AC, but we'll just do this for now. So M is equal to U, AB, dotted with the cross product of BC and F. So we can write this as our determinant calculation. Put the fifth out here. 3, 4, 0. BC 0, 0, 4. F, we'll not concentrate on F, but F minus 20, minus 10, 15. We can expand it various ways. Let's expand on this second line. So we're going to have our fifth outside the bracket. We're going to have plus, minus, plus, minus, plus, minus 4 multiplied by the determinant of 0, 0. Sorry, that's wrong. So we're going to take out these rows and be left with 3, 4, minus 20, minus 10. That's not minus 10, is it? No, we'll look at that to check that. That's plus 10, plus 10. So 1/5, moment is 1/5. Or minus 4 times 30 minus 80, which comes out to be minus 88 Newton meters. And you can do this using R is equal to AC. Check. that, you get the same moment. M equals minus 88 Newton meters. Exercise for you. Okay, thank you.